All right, so we are going to learn about our first gas law called Dalton's law. So there are several rules and laws that apply to how gases behave. And what Dalton's law says is that if I have a bunch of different gases in a container, all of them are putting pressure on that container as they're bouncing around. But if I put a bunch of different gases in there, each gas applies a different amount of pressure. And so Dalton's law allows us to calculate, well, how much pressure is each different gas putting on the container altogether? Because all of the gases are different, so the pressures that they put on the container are different. There are two ways to approach Dalton's law. The first way that we're going to talk about is by addition. So it's very simple. We're literally just going to add. So the total pressure of the container, or P total, will equal the partial pressures, P1 plus P2 plus P3. So of all the different gases that are in that container, each one is applying a partial pressure to the walls of that container. And this can go on and on and on. So what you'll need to remember is the number of partial pressures that you have is going to equal the number of different gases. So what that means is if I have two gases in a container, then I will have two partial pressures. If I have four gases in a container, I will have four partial pressures. So this law will kind of change. You'll have P1 plus P2, sometimes plus P3, P4, P5, however many of those will be equal to the number of gases that you're using. So if I look at this first question, I see two gases. It tells me we have neon and we have argon. So when I write the formula, which you're going to do every single time, I'm going to have two partial pressures because I have two gases. Now the question says, what will the total pressure be? That means X is here. I don't know that part. So now I need to find partial pressures for each gas. I see one here and one here. Because we're adding, it doesn't matter what order you do this in. So it's very simple. I just add those numbers up. 776, and then we will consider sig figs. There were 3 here and 3 here, so I want my answer to have 3, which it already does. And then the unit, you don't have to make it up, you'll just look in the question. Options for gas pressure could be mmHg, atm, or kPa. This question has mmHg, so that's what I will put on my answer. Now there's another thing that can happen is we can collect a gas over water. So that's what's going on in this picture. So if you look at this Erlenmeyer flask over here, I've got a reaction going on and it's producing a gas. I know that because there's bubbles in there. And what the bubbles do is as they form the gas, that gas goes up and gets collected in this tube. And I want to measure how much gas there is or what the gas is or the pressure that it's creating. So I'm going to collect it in this tube, and that tube is going to run into a tank of water. Now once those bubbles of gas get into that tank of water, they're still going to rise. And now in this section right here, we have two things. There's the gas I was collecting, but because this was collected over water, there's also a little bit of water vapor. Remember, that means basically water gas also in that tube. So whenever you have something collected over water, you have two partial pressures. One is from the dry gas and one is from the water. So anytime you see over water, your formula will be P1 plus P2. Oops, because this is whatever the gas is that you're talking about, but P2 is the result of the water vapor. So that might be a little bit tricky because look at how many numbers they give me. I see this, 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 but we just want pressures. So milliliters is not one of these pressure units, so we can cross that off. 20 degrees Celsius, that's a temperature. I don't care about that. There's another 20 degrees Celsius. I don't care about that. Here I have mmHg numbers. Those are going to be what I use to solve. So it says, what is the pressure of the dry gas? So I don't know P1. So that's where X is going to be. So then I'm going to look for, okay, what's my total pressure? That's right here, this 78.0. P2 is the pressure of the water vapor, and it says right here, the vapor pressure of water, so that's P2, is 17.5. Then we'll just solve using algebra. We'll subtract this from each side, and then I'm going to get x equals 87.1. Oh, no, sorry, I did that math wrong. Equals 60.5. Push the wrong button, sorry about that. Okay, then we just have to check out our sig figs in units. Both of these pressure numbers that I used had 3 sig figs each, so my answer should have 3, and it does. And then I'm just going to put mmHg because that's the unit that was given in the question. Okay, now there's another way that Dalton's law could be asked though. You could also ask it with percentages. So this formula is going to be a little bit different. We're going to have the partial pressure, so P1, right? And just like above, it's a partial pressure. It's just going to be in a different location in the formula. Okay. If you have a percentage, you're going to do percent over 100 times the total pressure. Okay, so same pieces, just arranged a little bit differently to get that percentage in there. So if I look in this question, I see here's a pressure, and then they give me a bunch of percentages. The question says, what is the partial pressure of oxygen gas? So I'm going to write this formula. I'm looking for the oxygen gas. So I'm going to find the percent, put it over 100, and multiply by the total pressure. Now, the way that you choose between the percentage is because I care about oxygen, pull out the 13. So I'm looking for this, 13 over 100, and the total pressure is that 670. So when I plug and chug that in my calculator, I get 87.1, and then we'll just think about sig figs. This pressure and this percentage both had 2 sig figs, so I need to make my answer 2 sig figs. Since this is a 1, I will not round up and it will become 87. And then we're looking for units. Again, if we're looking for pressure, my options are millimeters of mercury, ATM, or kPa. This question had mmHg, so that's what I'll put there. So now your job is to go through on the bottom, and we're going to try to solve these. The first thing I want you to do for each one is just write the formula. Are you using Dalton's law with percent, or are you using Dalton's law with addition? So for each one, just go through first and write the formula. Decide which version you need to use. Remember, if you need the law by addition, you have to figure out how many partial pressures you need. All right, so in this question, I do not see a percentage, which means we're doing Dalton's law by addition. So we have to figure out, well, how many different partial pressures do we have? I see 2 gases, oxygen and nitrogen, so it's P1 plus P2. In the next question, I don't see anything about percentage, so this is another Dalton's law by addition. So I know I'm going to have P total equals the number of different gases that I see. Again, they used oxygen and nitrogen, and that's it. So we have 2 partial pressures here. The next one, I see a whole bunch of percentages. So this must be Dalton's law with percent. So I'm going to write the partial pressure equals percent over 100 times the total pressure. All right, let's keep going. The next question, I don't see any percentages, so I know I must be using Dalton's law of addition, and it tells me about 3 different gases here. So that means my formula is going to look like this. P total equals P1 plus P2 plus P3, so that I can have all 3 gases. The next question, there are no percentages listed, so I must be using Dalton's law with addition. And I see something about carbon dioxide, and then it says 2 other gases. That means there are 3 of them all together. So I need to have 3 partial pressures. Lastly, I don't see any percentages, but I do see collected over water. So whenever you see collected over water, that's Dalton's law of addition, and we're going to have two partial pressures. This one will be the gas, and this one will be the water. Now that you've decided the formula, see if you can go through and solve each one. Then come back here and check your answers with me. All right, so let's work through this one. In this one, I'm looking for the partial pressure of the oxygen. That means my X goes here. So the total pressure that they tell me is 6.45, and the other partial pressure is 2.07. So I'm going to subtract from each side. So I get X equals 4.38. Each of my original numbers had 3 sig figs. My answer already has that. And they both have atmospheres for a unit, so that's what I'll put on my answer. The next question, it says I need to determine the pressure of the oxygen. So that's again one of my partial pressures, so X will go there. It tells me the total pressure is 758.00, and the other partial pressure, the nitrogen, is 527.0. We'll just solve using algebra. We'll subtract here. So I'm going to get X equals 231. Now this one for sig figs, there were 5 here and 4 here. Both of those numbers are Pacific. But my answer right now only has 3 sig figs. To make it 4, I'm going to have to add a 0.0 because 231 is equal to 231.0, but this has the sig figs that I need. Lastly, I'll put mmHg on it because that is the unit that we were given. All right, this next one's a little tricky. We know we're doing percentages, so I'm looking for the partial pressure of helium. So I need to focus on the helium gas. That means I need to find the percentage for helium gas. It tells me nitrogen is 59.3 and oxygen is 15.0. It doesn't give me this at all. But now you have to think about your math. You can't just ignore it. We know that percentage means out of 100. And I know that 2 of the gases are 59.3 and 15.0. So I should be able to solve for the percentage of the third gas. If I do 100 minus 59.3 and minus 15.0, this is going to equal the percentage of the helium. The reason I know that is because percent always means out of 100. That's the maximum score you can ever get on a test. So when I subtract all of this, I get 25.7%. That's the percentage that I need. Because they didn't give it to me, I had to solve for it before I can put it in my formula. Now I can go on. I need a total pressure. Here's a pressure number right here, 783.4. Plug and chug this in your calculator and you're going to get 201.3338, and then check out your sig figs. This pressure that we used had 4 sig figs. All of the other percentages had 3, so we're going to go low and choose 3. I'm going to leave this as 201. The 3 does not make it round up, and the unit's going to come from right here, my mmHg. All right, let's go over to our other column and keep solving. We know we're looking for addition, and it says I'm looking for the pressure of the carbon dioxide. That's one of our partial pressures. So I need to find the total, and it says it right here, total pressure of all gases is 183.4. So I need to find 2 other partial pressures. And I see 2 other numbers right here. The order doesn't matter because we're just adding. So then we'll combine these like terms. So I get 183.4 equals X plus, when I add those numbers, I get 77.1. Subtract that from each side. So I get X equals 106.3. And lastly, we'll think about sig figs. So I had 3 here, and 4 here. Given the choice, I'm going to go low, so I want 3 sig figs. The 3 does not make it round up though, so we're going to stop it at 106. And the unit that they gave me in the question, they were all mmHg. So that's what will go on our answer. All right, next one. I need to find the pressure of the carbon dioxide. That's one of our partials. It tells me the total pressure is 30.4 kPa. So I need to find the other 2 partial pressures. Those are given to me right here. So same thing as above, combine those like terms. X plus, when you add those numbers up, you get 27.3. Keep the 30.4 on the other side. Subtract. And we get X equals 3.1. And last thing is we'll think about sig figs. So I had 3 in this number, 3 in this number, 3 in this number, but the answer that I have currently only has 2 sig figs. So in that case, it's okay to add a 0, and the unit I was given is kPa. Last one. So we've got a collected over water example. So we know that we have to have a total pressure, pressure of the gas, and the vapor pressure of the water. It asks me for the partial pressure of the gas. So that means this is the X. The total pressure is this 762. I'm going to ignore this milliliter number. That's not pressure. I'm going to ignore the temperature number. That's not pressure. Here it gives me the vapor pressure of water. I know I need that. And that is 21.1. Then we're just going to solve like the other ones. Subtract. So you're going to get X equals 740.9. Now ignore those numbers we didn't use. Of the numbers that we used, we had 3 sig figs and 3 sig figs. So my answer should also have 3. This 9 though is going to make that 0 round up. So I'm going to get 741. The unit will be mmHg. And that's everything you need to know about Dalton's law.